Problem 1676. You are given the root of a binary tree and a list of node references. Return the lowest common ancestor of all nodes in that list, the deepest node that still has every listed node in its subtree. In this example, the list marks nodes with values 6, 2, 7, and 4. They spread across the left subtree. 6 is attached to 5, while 7 and 4 sit under 2. The shallowest node whose subtree contains all 4 is 5, that is the lowest common ancestor. Picture several marked spots in a tree, like hikers scattered on different trails but all heading for the exit at the root. You are not pairing two special nodes anymore, you have a whole team. Put those node references in a hash set so membership tests are instant. During a traversal, hitting any team member is a stop signal. That subtree has found part of the crew, and a summary of that result travels upward. Use post order. Children finish first, then the parent decides. If the current node is in the team, you already have a report from this branch. Otherwise you ask the left and right subtrees. If both return a non-null pointer, those reports met here. This node is the lowest place that combines those branches. If only one side has news, you pass that pointer up, just like in the two-node LCA story. The lowest common ancestor for the full list is the deepest node where every target finally sits in one combined subtree. In this example, that first full merge for all 4 marked values happens at node 5. Because the recursion returns bottom-up, that meeting node is exactly what bubbles to the top as the final answer. Step 1. Treat every listed node as one team. Copy those references into a hash set so each visit can ask in constant time whether the current node is one of the targets. On screen we show the list becoming that set, then we paint each target its own color so you can follow its signal. During the depth-first search, as soon as the current node is in the target set, we return that pointer immediately and we do not recurse into its children. That prunes work. The node already certifies itself as a required member. Here the leftmost target is node 3, watch a return signal run up toward its parent. After the left and right children finish, node 2 compares their answers. The left side found target 3 and the right side found target 4, so both subtrees returned a non-null pointer. That means node 2 is the lowest place where those two branches meet. It becomes the combined report for this whole left chunk. The same rule applies at the root. The left child hands up the summary from node 2's subtree, and the right child hands up target 5. Both sides are non-null, so the root is the lowest node whose subtree contains every listed value, that is the lowest common ancestor for the full set, and the recursion returns it. Let n be the number of nodes in the tree and k the size of the given list. Time is linear in n. We run a single depth-first search and each node does constant time work including hash set membership. Space is order k for storing the target references in a set, plus recursion stack depth on the order of the tree height, linear in n only in a tall skewed tree. Pseudocode for lowest common ancestor of many nodes. The function takes the root and the list of node references. Build a set of those references for constant time membership tests, as in the solution seen. Define an inner depth-first helper on a single node. Add a null pointer, return null. If this node is one of the targets, return it immediately and do not search deeper. Otherwise recurse on the left child and store the result in A. Recurse on the right child into B. If both subtrees return a non-null pointer, this node is the merge point for that part of the tree. Otherwise relay whichever side had the answer. Start the recursion from the root and return its answer.